All right, number 6, we want to determine if the function is even, odd, or neither. So what do they mean? Even, odd, or neither. This is checking symmetry. And so there's some mathematical formulas that I'm going to give you. F of x is just a notation. It just means y. All right, so what we're going to do is we're going to check if the original function is equal to negative f of x. Okay. So if we change the y value, this would be x-axis symmetry. Okay, this is one that they don't check. We check to see if f of x is equal to f of negative x. So you change the sign on the y on the inside this time. This is y-axis symmetry. This is the one we refer to as even. And then we can also check negative f of x with f of negative x. And this is called origin symmetry. And this is the one we refer to as odd. So really we're only doing 2 things, and then we'll make these comparisons, okay? So our original function, g of x in this case, is equal to 3x to the 6th minus 9x to the 4th plus 6x squared. We are going to compute negative g of x, and we're going to compute g of negative x, and then we're going to make these comparisons. So negative on the outside just means put a negative on the outside, and we're going to multiply this whole thing by negative. So distributing a negative, this would be a negative 3x to the 6th. Negative times a negative is a plus 9x to the 4th. Negative times a positive minus 6x squared. So here is my negative g of x. All right, and then g of negative x. So what that means is we're going to plug in a negative x. So we have our original function 3. Plug in a negative x to the 6th minus 9, negative x to the 4th plus 6, negative x squared. So what happens? We're going to be raising x to a even power. So anytime you have a negative to an even power, negative times a negative is a positive. Well, let me just do negative signs. Negative 2, 3, 4, 5, 6. Okay. So mainly we're multiplying, and so I'm looking at all these signs being multiplied. Okay. So 2 make a positive. 2 make a positive. These 2 make a positive. So if you have an even number of negatives, when you multiply, it's going to come out positive. So this comes back out positive. This is 4 of them, comes back out positive. 2 of them comes back out positive. So all of these terms come back to their original form. Because we're only raising that negative x to the power. So when we do our comparison, we're looking at this guy, and this guy. So f of x, or my g of x in this case, and the negative, I'm looking and seeing, are these the same? And the first term violates that one because this is positive, this is negative, so it doesn't have x-axis symmetry. Okay, so now I'm looking at this f of x and the negative. So that means this one and this one. And these are exactly the same all the way down, so that this function comes out even. And then we compare these 2 together, negative and the g of negative x. And again, the first term violates that because they have opposite signs. So this function is even, and that is it. Now, you can look at the power, and it would suggest that if it had symmetry, maybe it would be even, but it doesn't always mean it is even, because there could be a shift or transformation that moves it and makes it not even. So you do have to go through and check.